nothing in the 9th grade. Does everybody understand what I'm saying? I don't know how far you got. I don't know where you ended. So I'm going to start from the very beginning. And I'm going to go to where I need you to be in the 10th grade. Okay? Okay. Now, please notice it is multiplication, which means that is all we are going to do. We are only going to be multiplying. But you're going to hear a few different words that maybe you don't either know or don't remember. So let us begin, cabbages. A polynomial is an expression using a combination, and I'm lazy, so I'm going to write combo of constants and variables. Sometimes coefficients are involved. Now, you do know what all those words mean. So here's what I'm going to do. I'm going to highlight constant, I'm going to highlight variable, and I'm going to highlight coefficient. And then I'm going to write a polynomial that has all of those things, even though you all know what they are. 3, we always use x. 3q plus 7. Where is the constant? 7. Why? Because it's always 7, no matter what. Where is the variable? Q. Why? Yeah, it's not a number. You don't know what Q is. Q could be anything. Therefore, it is variable. And the coefficient is 3. What do coefficients do? Multiply. And we have already used coefficients in our radicals, right? And in our exponents. Everybody cool? You all know this already, right? You have heard some of these words? I'm going to trust that as a yes. Polynomial comes from Greek for many numbers. Monomial. Mono. 1. A monomial is any variable. I need an A there. Any variable coefficient or a constant connected by multiplication. Monomial is 1. So, is M a monomial? Yeah. What number should be in front of M that we don't write? 1. So M is a monomial. What about M squared? Yes, because that would be M times M. There's only one of them, so it's M. Everybody cool? What about 3? I don't want to use red again. What about 3M squared? Is that okay? 3 times. Trust me, Sage. You'll get it. The very next one, you'll be like, okay, I see. Actually, no, I'm going to need to do 2 more before you see. What about this one? This is where kids start to get screwed up. 3m squared, n squared, o squared. Is that a monomial? Yes, because it's all still connected by multiplication. So all of that is okay. Everybody cool? Now what about this? 3m plus 7. No, because we're no longer just multiplying. This becomes the binomial. which down here means two of them. So a binomial is two monomials connected by what? Yeah, connected by addition or subtraction. Now, of course, we all know that subtraction is just adding negative numbers. So really it's connected by addition, but that's what a super math nerd would say. For our purposes, we can say addition or subtraction. Everybody understands what I mean, right? Okay. So let's remind ourselves. 3m squared n squared minus 2m. Is that a binomial? Yes, because there's a minus in the middle. Everybody cool? Okay, what about this one? 3m minus 2m. As it's written now, it is, right? When we simplify it, is it? No. What's going to happen when I simplify that? It's going to become m. So this part, binomial. But we would simplify it. Everyone is cool? Yes, it would make it a monomial. Okay? Now, being the intelligent young people that you are, you obviously know that trinomial is 3. You obviously know that if a binomial is 2 monomials, what's a trinomial? 3 monomials. Connected by what? Add, addition, or subtraction. Each of these is called a term as well. So a binomial has 2 monomials or 2 terms. A trinomial has 3 monomials or 3 terms. There's no other special names. We don't have quadrinomials, quintinomials, sextinomials, septinomials, octinomials, nonomials, decanomials. We don't bother. After 3, we just say polynomial. Okay? Now, I recently did get my hands on a textbook where they were actually calling them quadrinomials and quintinomials. Why? It's so dumb. I don't know why they would ever do that. I do know why. It's so people that study math can feel smarter than regular people. That's why. That's the only reason for it. That's the only reason anybody has funny words for things that can be explained simply. It's so they can feel smarter than the person they're talking to. Right? But, that's just my opinion. My opinion's been known to be wrong. Everyone is good. Yes, this is not news to any of you, right? Okay. This might be news to some of you. Because in grade 9, you didn't deal with very large polynomials, did you? Right? Like the biggest thing you dealt with in grade 9 was probably a binomial, right? Correct me if I'm wrong, because I didn't teach any of you grade 9. You did a couple of trinomials? Okay. So the degree of polynomials is found by adding the exponents of the variables in each term. So 3x, what would that guy's degree be? 1, because there's a variable with an exponent of 1. Easy peasy, right? Okay, so that guy is a first degree polynomial. 2x squared, what's that guy? That would be a second degree polynomial. Everybody still cool? Okay. 3xy. What would that guy be? A second degree polynomial. 3xy squared. What would that guy be? Third. Okay. Now, don't write this one down. Just think about it. 3xy squared plus 4xy. What do you think is the degree of that binomial? So Satjot's guess is 7. Why? 5. Okay, Satjot's guess is 5. 5 is what everybody says? We all... Okay. The weird thing here is when we have more than one term with variables, we only look at the biggest degree. So this would be a third degree polynomial. Did you say 3, Sage? Nice. Okay? Because each of these terms is their own thing. Everybody cool? This is not very important in the 10th grade. It's not even very important in the 11th grade. It gets important as you go further on and your polynomials get bigger and bigger and bigger. Because we like to write our polynomials in descending degree. So the biggest degree goes first. But we also like to do it in alphabetical order. Descending exponents of x. So we start with the biggest degree of x, and then do all the x's, and then move on to the biggest degree of y, and do all the y's. Does everybody understand? It's not important. Don't stress about it, but I am supposed to have made you aware of it before you go forward. Does everybody feel aware? Good. Now forget it. It doesn't matter. Okay. But I'm whispering this because I'm hoping the mic won't pick it up. Oh, I didn't plug in the good mic, so there's no way this is getting picked up. Okay. Okay. Now I'll plug in the good mic. And we're back to math class. What I mean by that is this. If I had 3x cubed y to the 4th plus 7x squared y to the 5th plus 8y to the 9th. If I wanted this in the proper order, no, because x is alphabetical. X would go first, x to the 3rd, then to the 2nd. Then I start with the y's. Everybody understand? Oh. But again, I don't care. I'm going to look at your polynomial. If you have all the right terms there, I'm giving you full credit. Okay? It's still blue, isn't it? It's not even paused. This is a new low. Quality. Hey, we're back. Okay, so that is in the right order. All right. If I had, for example, a z squared there, still the y would go first. Even if that was like z to the 10th. Okay. All right. Now, we are not going to get out algebra tiles and play with blocks. But, again, I do have to show this to you. I don't like them. I think they have 1 or 2 good uses for 1 or 2 people per class. But for some strange reason, the government decided that everybody needs to learn it. Now, some of you can do all of the math we're going to do in this unit, all with numbers. But there's always 1 or 2 that are like, I don't get it. And then they see the picture and like, okay, I get it. So for me, that should mean that if you don't get it with numbers, I should use the blocks to show just those people that don't get it with numbers, right? But I don't run the government, so I have to show it to everybody. All of you should have seen this in the 9th grade. Yeah. What's that? That's 1. What's that? -1. That is a bar that is, no. That is an indiscriminate length. You don't know how long that is. If you don't know how long it is, what is it? It's unknown, so it's x. So what is this? Negative x. Now, if I take that x and I stretch it the same distance this way, I have x down here and I have x there. So what's this? X squared. And if I shaded it in, it would be negative x squared. You all know this already. We're going to do like 5 of these and no more. Okay? Yeah, I don't like them either. But they do have one use that I think. I have found one really good use for them. And it's this. Just on an aside. 3 minus minus 4. What is the answer there? What is 3 minus minus 4?
7.
7, right? Because 2 negatives make addition. The reason I like algebra tiles is they actually help. Because 3, I would draw like that, right? What does minus mean? When I say minus, what are the words you actually say in English? Take away. So this says have 3 and then take away negative 4. Are there any negative 4s there to take away? No. But if I put 4 negatives there and 4 positives there, what does a negative and a positive equal? 0. So I have added 0 here, haven't I? I still have my first 3 and then I added 0 4 times, right? Now, can I take away 4 negatives? And what's my answer? 7. That's why I like algebra tiles. I think they're very useful. I think they should be shown to grade 6s when you first learn about negative numbers. And then I don't like their use after that. But that's just me. If you like algebra tiles, you want to use them for this whole unit, you're welcome to use them for this whole unit. I can read them. It's not like it's, hieroglyphics to me. Okay? All right. Do you like how I used the hieroglyphics there? I was classy, hey? Smart guy. Ow! Not that smart. I just bashed my tooth with my cup. All right. So, if you were reading this to me in English, what would you say? 5 times x plus 1, right? Okay. So, if I were to draw x plus 1, it would be x plus 1, yes? How many times would I need to draw it? 5 times. Agreed? What shape did I just make? Cube? A square? A rectangle? How long is this side? How long is just that? 1, 1, 1, 1, 1. 5. How long is that? X and 1, yes? The numbers on the outside are the factors. Because 5 times that. The numbers on the inside are the product. And of course, it's just like a regular rectangle, right? The area is 5x plus 5. Everybody cool? You know this already. Algebraically, that means 5 times x plus 5 times 1. So simple. And yet, people have trouble with it. Everyone is good, yeah? All right. Now, that is what is called the distributive property. Some teachers give it a cute little name. Yeah. Some people call it flying arrows. Some people call it leapfrogging. Some people call it all kinds of fun names. You know what I call it? Distributive property, because that's its name. AX plus Y equals AX plus AY. What if it was ax plus y plus z? What would it be? Ax plus ay plus az. What if it went on forever and ever and ever? What would you keep doing with that a? Multiplying it by every single term inside the brackets. That's it. For some reason, people have trouble with that. Can I forget about all my other rules? When I'm doing distributive property, do I get to forget about exponents? No, of course not. So what would be 3x squared times x plus 7? Oh, now everybody shuts up. What would this be? Oh, there's a lag? Oh, all right. Never mind. My fault, not yours. I can see it. So what would that be? 3x cubed plus 3x squared times 7, which would be 21x squared. Right? Okay. Everybody can do the distributive property. I believe you, but I need you to prove it to me once that you can do it with a picture and with algebra. I know it went blue, so draw the picture. What are the factors in that first question? There is x, and the factors go on the outside, yes? There is x, and up here there is 1x, 2x, and negative 4, correct? Now fill it in. X that way and x that way. X that way, x that way. And then positive times a negative. What wins? Negative, just like in real life. I'm just kidding. What's the answer? Where does the answer live? Inside or outside? Inside. And what is it? 2x squared. Technically, it's plus negative 4x. Would a math guy write it that way? 2x squared minus 4x. But I am very happy Sage brought that up because I would have said, I thought most of you would have said this one, and then I would have said, but technically, what is it? It's technically 2x squared plus negative 4x. So Sage got the technically in on me first. Sneaky. And of course, with algebra, x, 2x minus 4 is x times 2x minus, or plus, x times negative 4, which is 2x squared plus negative 4x, which is 2x squared minus 4x. Now, this way in textbooks that you will be using later in your life is also called symbolically. Because numbers are symbols, right? Not like ba-da-ba-da-bum, symbols, this spelling. How many fingers am I holding up? No, it's 5. Your thumb's a finger. It's got 3 joints. It's a finger. I'm holding up 5 fingers, right? So we would not do, because we're grown-ups, we would not say Mr. Myers has 1, 2, 3, 4, 5 fingers, would we? We would say 5. That symbol represents 5 things. One symbol represents 5 things, right? What? Down at the bottom. 1, 2, right there, 3. Finger, 1, 2, 3. So, you guys do this one. I'm going to make you do this 3 more times, and then I'm never going to make you do it again. What's the picture look like here? Three X's. Does it matter where you put the 3 X's? No. You can put them down there or you can put them there. I'm going to put them here. And what's then down here? X and 2 little guys. 1, 2, 3. 1, 2, 3, 4, 5, 6. What's the answer? 3x squared plus 6x. Right? You can do this in your head. You're smart young people. I'm very proud of you. Let's move on. Can we move on?
Yes.
Excellent. What's different now? There's still two factors, right? So there's no difference. There's still factor 1 and factor 2, right? Where do the factors live? On the outside. So x, 1, 2, 3. Agreed? X, 1, 2. Agreed? So what's this one going to be? X by x. Easy peasy, right? X by 1. Easy peasy, right? X by 1, x by 1, x, or 1 by x, 1 by x, and then 1 times 1, and 1 times 1. What's my final answer? X squared plus 5x plus 6. Yes? Picture. Algebraically, x plus 3, x plus 2. If there was no 3 there, what would you do with that x? It would be x times x plus 2 times x. Agreed? If there was no x there, what would you do? 3 times x plus 3 times 2. Correct? Now, what is x times x? X squared. What is 2 times x? 3 times x. If I have 2 x's and 3 x's, what do I have? 5 x's plus 3 times 2, 6. Now, here is something that you were probably taught in the 9th grade, but not necessarily. You were probably taught this acronym, FOIL. Nobody has seen that? Sweet. Good. Because usually that's taught to grade 9s, and I don't like it. So I have to teach it again. FOIL stands for first, outside, inside, last. And here is what it means. X plus 3, x plus 2. First, you multiply the first thing you see. X times x to get x squared. Then you multiply the outsides. X times 2. Then you multiply the insides. Now, here is where some of you may have seen this, and your teacher probably showed you this. And then last, plus 6. Probably showed you this, if you've seen it. And then your teacher said, now, after you've done your multiplying, look for like terms. Then you combine them. And your teacher may very well have said, draw shapes around all the like terms so you can keep them together. Triangles, circles, whatever. Each shape that is a like term gets the same shape, right? I would like to offer you a different option that I find makes this easier, because when there's only one like term, it's super easy, right? But when there's more, it makes it difficult. I would like to submit to you this. Notice we started with the x and we multiplied it through. I got x squared plus 2x. Now I'm starting a new term. I like to start a new line. 3 times x is plus 3x. And then I group them vertically. And then 3 times 2 is 6. Now, your like terms are already held together. X squared plus 5x plus 6. I don't really care. Now, I said at the beginning of this that I don't like FOIL. The reason I don't like the term FOIL It's because it applies to first, outside, inside, last, yes? What if I had this? Can I do first, outside, inside, last? No, because I got too many over here. So I don't like the term FOIL. I like to say its proper name, the distributive property. The first one will distribute all the way through. So what will I get here? X cubed. What will I get here? 2x squared. And what will I get here? 7x. Agreed? Now, am I done with the x? Okay, so I'm going to move on to this term. It's a new term, so I'm going to start a new line. What do I get there? 3x squared. I already have some x squareds, right? So I just line them up vertically. What do I get here? 6x. What do I get here? Plus 21. What's x squared plus nothing? Or x cubed plus nothing? X cubed. What's 2x squareds plus 3x squareds? 5x squareds. What's 7 plus 6? I'll help you out there. What's 0 plus 21? 21. Everybody see? I like to stack them because it keeps them together. If you don't like to stack them, do you have to stack them? No, because I am not your grade 3 teacher. When you do something different than me, I don't care if you get the right answer. Sage.
I don't know if this makes sense, but what if you had x squared plus 3 times x squared plus 2, and you just do the exact same thing, but they're all different?
So you're asking x squared times plus 3 times x squared plus 3? Same thing. That would be x to the 4th plus 3x squared. And then a new line, plus 3x squared plus 9. X to the 4th plus 6x squared plus 9. It's a good question. There's nothing wrong with that. Is everybody good? Now, the other reason I don't like this right here, would this work with this? No, because how do we draw an x cubed? We'd have to be drawn x squared up top with an x here, and in there we'd have to be drawn this. Right? I mean, we could do it, but what a pain in the ass, right? So let's learn it with numbers, shall we? Notice how nice I am. I don't need a picture here. I just want an algebra solution. So, what do I multiply first? X times x. Do I need to draw the arrow?
No.
X squared. What do I multiply next? Plus 4x. New term, I'm going to use a new line. What's negative 1 times x? Negative 1x. And what's negative 1 times 4? And then I add it up. X squared, what's 4 minus 1? Plus 3x. And what's 0 minus 4? Negative 4. Now I'm going to give you another gift today. Look at that. It is like Christmas. Look at that. Everybody's looking, right? This was the multiplication, right? This was the answer, yes? Do you see any commonalities or any patterns between 3 and 2 anywhere in this answer? 3 times 2 is 6. That was 3 times 2. And that is 3 plus 2. Everybody see that? Now, if it happens once in math, how often does it happen? Let's check. Does this look like that last one? Starts with a single variable and then has a constant, right? Okay, so we got x squared because we know x times x. Now, is there a relationship between -1 and 4 and 3? What is it? 4 minus 1 is 3. 4 minus 1, x. And is there a relationship between 4 and -1 and -4? What is it? 4 times -1 gives me the last one. So, if I were to write it out like this, x plus a, x plus b, notice I can only have a single letter there. What is the answer? X squared plus a plus b with an x, and then what did we do with these two to get the 4? Multiplied. So what do I do with a and b? A, b. Everybody cool? Don't write this down, just look. X plus 3, x plus 4. The answer is x squared plus 7x plus 12, right? Because I added, then I multiplied. Now, if I write it out the long way, x squared plus 4x plus 3x plus 12. X squared plus 7x plus 12. Everybody cool? Notice this shortcut only works when? When it's just a single variable. But it's a nice little shortcut for all of those questions, right? Okay, I'm done. Page 122 and 123 are homework. I want you doing them now. You can finish up. You got 18 minutes. After you see the right answers Monday, you're going to do page 124 as an assignment. Okay? Now, I want to warn you of something so you don't go all the way through this doing something wrong. X squared. What does that mean? It means x times x. Why? Because x is the base, right? And that 2 means I got to have 2 bases. Agreed? So what then is 2x squared? 2x times 2x. Everybody's cool? Okay. What then do you think is x plus 7 squared? X plus 7, not plus, times x plus 7. Okay? When we're doing this, you people want to bring the exponent to both of them. Can you do that here? No. Why? Why is this not x squared plus 49? What's the base here? X plus 7 is the base. When you square a base, you have to have 2 of them, don't you? So you get x squared plus 7, 14x, 7 times 7, 49. Same way we did with the little shortcut. 7 plus 7 is 14. Now, if I was writing it out in the long way, Satjod, it would be x squared plus 7x plus 7x plus 49. 7 and 7, 14. But because I only have a single letter at the front, I can do the little shortcut. Everybody cool? Everyone is good? All right, page 1, what did I say, 122? 122 and 123 is today and homework. You see the right answers Monday? On Monday, I'm going to give you 10 minutes, maybe 15 minutes to do page 124 as an assignment. Now, some of you will do that over the weekend, and I won't be able to stop you. I can't even keep a straight face. Go.